All right, quick check-in with Theodore. See how he's doing before we do some derivatives. He looks like he's wide awake, ready to learn. Hopefully you are also wide awake and also ready to learn. Let's talk about what a derivative actually is. And yeah, in the book, page 87, there are so many definitions of the derivative. I kind of want to show you, but I'm not going to because I don't have it ready. But lots of things the book says about the derivative. Page 87, if you want to look. We'll talk about some of them. So, the derivative of a function, let's call the function f, the derivative at some point is the instantaneous rate of change. It's how is the function changing? Okay, so over here, if I say the derivative right here is 4, hold on, I have to show you where here is, right? If I show you the derivative here is 4, that means the slope of the function, how the function's changing right here, is it's increasing by 4 outputs for every 1 input. It's a slope, okay? The rate of change of the function right there. It's also the slope of the tangent line. That's how we found it in the example before. So if I tell you the derivative is 4, that means the slope of this tangent line is 4. All right. It's also known as the slope of the curve. All right. So if I say the derivative over here is something else, that's a measure of how steep the curve is right here. How steep the curve is the same thing as how steep the tangent line is. Those are the same. So a lot of words that we use to talk about the derivative, it's all three of these things. Instantaneous rate of change, slope of the tangent line, slope of the curve. That's all derivatives. The important thing is derivatives are slope. We've spent so much time in pre-calculus, if you're in my class, definitely, and if you're in other classes, probably, talking about slopes and interpreting slopes. That's important, hence the in pre-calculus, because of derivatives. Derivatives are just slopes. All right. If you don't remember anything else from this video, derivative is slope. So a couple other things. If the derivative exists at some point, we say that f is differentiable at that point. It can be differentiated. The derivative is possible. And this is really the formal algebraic definition. We won't be using this very much, but we did actually just do it in the last video. I kind of tricked you all, right? It's just the slope of the secant line as those secant lines get infinitely close together. H was just how far apart were our points. And then this is the rise. And that's the run. This is just rise over run. Rise over run for a derivative because the derivative is slope. All right. So a little bit of notation. We write it as f prime of x. This is very common, f prime of x. Sometimes we'll write it as y prime, or it could be other primes. If our function is g, it would be g of x. If we're looking at some cost function, its derivative would be c prime of x. All right, that'd be the derivative of the cost function, which we'd use to approximate marginal cost. All right, not too many business applications yet in this class, but we will be incorporating more of them. I have to get through some of the theory first. And then there's another notation because Newton and Isaac Newton and Gottfried Leibniz developed calculus around the same time, and they use different notation. You could also see this, df dx or dy dx. That just means the derivative of y with respect to x. That's what each thing means in that notation. So let's just get some practice using this notation, all right, using these concepts and definitions. Let's look at this graph, this cubic graph. Do you think f prime of -2 should be equal to -2? Why or why not? Think about rates of change. So let's locate -2 for this function. So -2 is right here. What does this mean? This whole thing means the slope of f when x equals 2 is negative. Negative means going down, decreasing. But what do we know about this slope of the function? The slope of the function is the derivative. It's the same thing as the slope of the tangent line. But if I draw the tangent line here, that's not a negative. That doesn't have a negative slope, right? This tangent line, as we look at it from left to right, is going up. So this can't be the right slope. This can't be the right derivative. This mathematical equation translates to this sentence, which is not true. So, no, it can't be. The derivative should be positive. And we should be able to get a little, like we can use the graph to get an approximation, right? This is what I think the tangent line looks like. The slope of this tangent line is kind of close to 3 or 2. Should be between 2 or 3. Right, we can look at the slope of this line just with rise over run. Up 2 over 1, the slope is about 2, maybe a little bit bigger. All right. What do we think the slope of the tangent line is when x is equal to 3? Well, x is equal to 3, that's like right here. Well, it looks to be 0, or maybe close to 0. All right, this is kind of what our tangent line looks like here, no? Maybe it's a little negative, I don't know. But we're going to guess that the slope of the tangent line when x is 3, right? Slope of the tangent line is just derivative. Derivative is the slope of the tangent line. It's the slope of the function. It's the instantaneous rate of change. It's your speedometer. Okay? If you have a position function, the derivative is your instantaneous rate of change. The rate of change of position is velocity. That's your speedometer. We think this should be something close to 0. Maybe not 0 exactly. But the slope is it's basically flat at that point. Do you think dy dx, remember dy dx is just the derivative, it's just the slope, is positive or negative when x is equal to 0? X equals 0, that's right here. Dy dx is the slope. Slope is, are we going up or are we going down? From left to right. We're going down. You can see that the function is going down. That'd be enough to say the derivative is negative, that dy dx is negative. You could graph a tangent line and you could see the slope of this tangent line is negative. Going down, maybe it's about -2 or something. Again, the way that I'm approximating this is I'm just looking at 2 points on this tangent line, looking at rise over run. Looks like it's going down 2, right 1. Slopes of lines, very important. So yeah, I'd say it's negative. Right, the slope is negative. Derivative, same thing as slope. Dy dx literally means derivative. All these concepts are all kind of the same. We could say that f prime of 0 is negative this way. Say the function is going down. These are all explanations for our answer. Okay? That's really what we're doing here. In the next video, we got more practice with this, but that's basically what we have. Derivative is slope. Derivative is slope, derivative is slope, derivative is slope. Slope of the function is the same as the slope of the tangent line. I'm going to be saying these words at you so many times. Hopefully they don't lose their meaning. We'll have pictures whenever possible. Good luck. Sayonara. I'm trying to think of more sign-off words.